Okay, question 8 gives us two functions, f of x and g of x. And part A wants us to find what f of g of x is. So just like the notation looks here, we're trying to plug g of x into f of x. So that would be 5 over x to the fourth minus 1. You okay with that for part A?
Yes.
Okay, part B, where is this discontinuous? So that would be where it does not exist, and where it would not exist is when the denominator equals 0. When you try to divide by 0, you either create a hole or an asymptote, vertical asymptote. Either one doesn't exist. So we get this. We could add the 1 over. We could take the fourth root of both sides. And then I'm kind of skipping over something here. 1 is a place of discontinuity, x equals 1, but there's another one as well. Negative 1. So just like when you take the square root of both sides, if you take any even root of both sides, you've got to consider plus or minus. So whether I plug in positive 1 here or negative 1 here, it would be division by 0, which means it doesn't exist, which means it would be some kind of break in the graph. Okay, before I move on, I want to make sure that no one has any further questions about 8. Okay, what you got?
It's kind of similar, but can you do, so like you have difference of squares, so this is a 4, can you do like difference of fourths? You know what I mean?
If it was something like this, it does factor. You wouldn't memorize it as a new formula, difference of fourths, because you could start off with difference of squares, and then part of it is still difference of squares. So as long as you're careful to factor it completely, you don't have to like learn a different formula.
Yeah, that's what I was asking. Like, can we do that for, did that always work with fourths, or is there a certain?
No, it'll work.
Okay.
Well, I mean, assuming it factors, like if this was, I mean, this wouldn't be a perfect fourth root there, so I would say that's not very useful. Like, it doesn't come up that often.
Okay.
Not often enough that I would bother learning something new for it, at least.